I'm here with Soki and Palomo. They're here to help me with Piecewise Functions. Here's an example of when to use a piecewise function. It costs $10 a week to feed Soki, but it costs $20 a week to feed this guy, Palomo. We can illustrate this scenario using a piecewise function. Here's a great piecewise function, and it illustrates what we were talking about with the cost of food for each weight category of dog. Here's Soki down here at $10 because she weighs less than 20 pounds. From 0 to 20 costs $10. Here's a medium-sized dog, and that would cost $15 for dogs weighing 20 to 40 pounds, and any dog over 40 pounds will cost $20. Here's Soki, here's Palomo, and here is the step function or piecewise function represented in equation form. A piecewise function is a combination of functions. And so what we really want to do is look at what's going on in this piecewise function. Now here's a g of x, could be f of x, h of x, but it's g of x and it's really y as a relationship with x. So we could just call this y equals. Now there are three functions here. And the first function is really, I like to look at it as y equals x minus 2. Now that's a line, right? X minus 2 with a slope of 1 and a y-intercept of negative 2. That's the function y equals x minus 2. However, it only occurs as this function if x is less than or equal to 5. So when x is less than or equal to 5, we can use this as the part of the piecewise function. Y equals negative x squared. Well, that's a quadratic function, and that would be a parabola opening down. Y equals negative x squared. But that only occurs between 5 and 8 on the x-axis. So at that time, you would see the part of the parabola over that section. And the third, y equals 6, which is just a horizontal line at y equals 6. But that only occurs in the piece of the function that is greater than 8. So this first example, we'll be graphing all of these and seeing where they occur. But the first type of problem is to evaluate the function for these values of x. So here we are. When x is negative 8, that falls into the first category or the first function because x is less than or equal to 5. We plug it in here. G of x equals negative 8 minus 2 equals a negative 10. So when x is negative 8, we're using the top piece of the function, and g of x equals negative 10. Now, what about when x equals 5? Look at that. It's also x is less than or equal to 5. X is equal to 5. We get g of x equals 5 minus 2, and that's 3. What if x is greater than or equal to 8? Well, when x is 10, we use the lower section. And when x is 10 or greater than or equal to 8, g of x equals, do we need to plug in x equals 10 anywhere? No. G of x equals 6. let's evaluate the piecewise function for x equals 6. I'm going to do one more. X equals 6. Let's do that one. When x equals 6, which piece of the function are we going to use? When x equals 6, that's between 5 and 8. So we'll use this second piece of the function. And that is g of x when x equals 6 is negative, but the negative stays there. There is a negative out here in front, and we're only going to square the 6. And so that, when 6 is squared, that's 36. But that negative stays with us. That's why I wanted to show you this, because if there's a negative already out there, we're going to square the 6, and the answer is still negative. Finish it off. Now, what we want to remember when we're graphing piecewise functions is to graph lines and simple quadratic functions. So let's look at these two pieces of this function. F of x equals -1 if x is less than 0. So all my x is less than 0 coordinates, the function is f of x equals -1. Well, that's like saying y equals -1. So we know how to graph y equals -1, and it's really just a horizontal line at -1, and that occurs for the entire function when x is less than or equal to, fill in that circle, 0. Y equals -1 or x is less than or equal to 0. What's happening when x is greater than 0? Y equals x plus 2. Now that's a linear function with a slope of 1 and a y-intercept of 2. Y equals mx plus b. Our y-intercept is 2, but this only occurs when x is greater than 0, so not at 0. So I'm going to put an open circle. That's my y-intercept. And I'm going to use my slope of up 1 over 1 to get the rest. And I'm just going to sketch that. That's a linear function when x is greater than 0. That's some pretty cool looking graph for a piecewise function. Here's another great one for easy practice. Here's a piecewise function. It's two functions, a combination of two, and we have f of x or y equals 2 if x is less than -2. So here's x at -2, and when x is less than -2, y equals 2. That is a horizontal line at y equals 2, and we go all the way up to a -2, but not including -2. That's a y equals 2 horizontal line, but it only occurs at x is less than -2. Now, if x is greater than or equal to a -2, we can graph this line. Now, I'm going to graph the line, and a lot of times you'll have to use an eraser. You can graph what the line would look like everywhere, but then you're going to use some restrictions that only happens in certain areas. I'm going to use the marker for this one, but on the next one we might need to use a pencil. We've got a y-intercept at +2. We're just going to graph the line. And then we're going to use a slope of -1, down 1, over, down 1, over. And there is our slope of -1, and that's the line, and it would go normally in both directions forever. However, in our piecewise function, we're saying it's only occurring when x is greater than or equal to -2. So actually we can extend this line all the way till we get to -2, and that is when x is greater than or equal to -2, we can draw the line. Now, here's a really good one, and it illustrates how you have to look at what the function would look like for any values of x, and then you choose those values of x, and you might have to erase parts of the function, but this is a kind of a good example to see how we do that. So I'm just going to look, and this is pretty simple to start out. H of x is 1 if x is less than or equal to -2. So y equals 1, a horizontal line at 1, but only if x is less than or equal to 2. So I'm going to come over here to 2, and if x is less than or equal to 2, it's a horizontal line, y equals 1. That's the easy part. Now, y, or h of x, equals x squared if x is greater than 2. So we know that x squared is the parent function of a parabola, and that's the most basic parabola. So let's remember that y equals x squared is a parabola, and I'm just going to sketch it lightly. It goes through 1, 1, and it also goes through 2, 1, 2, 3, 4, and I'm just kind of sketching the parabola. This is what the parabola would look like for all values of x. And I'm going to sketch it. It's just a real light parabola. However, this parabola for this piecewise function is only happening at x is greater than 2. So it's increasing pretty rapidly and going on up here all the way from 3 to 9. It's actually increasing quite rapidly. But we're just going to keep on going up here, because after x equals +2, not including +2, that's the only place where the parabola is occurring after x equals 2. So we can erase, because before, or when x is less than 2, the parabola is not occurring. It's actually, the function is x, y equals 1. So I'm just going to erase that, and I'm going to say all the way up, less than, when x is less than 2, the function is y equals 1. And when x is greater than 2, it resembles the parabola. That is my piecewise function. Peace is all around us. Just have to look for it. Here's your try. Pause the video, try them on your own, and then watch the quick solve section in the next part to see if you got them right. Have fun and peace. Thanks for helping, Palomo. And thank you for helping, Soki. And thank you for watching.